All right, so Lab 14, we'll go over Lab 14 real quick, and then we will talk about the finals more, if that's okay with everybody. And the Lab 14 actually should go pretty quick. There's not too much to do. It is a slightly more, I would say it's a little bit more complicated than Lab 13 was, but it's going to be fewer tasks. Turn up the volume. Yes, we can do that. Is that any better? Is that any better as far as volume? Okay, perfect. So yeah, we're gonna be we're gonna be going over because last week we kind of just got the server ready in a sense, and then as a test we kind of built Apache, got it working with Flask and WSGI. And that's kind of like a precursor to what we're going to be doing. And that's just to make sure your Apache's really working. And what we're going to do in part 2 is we actually build the database, and then we connect the database, set up Flask, and connect them. Is kind of like the big thing we're going to do. So we're going to jump right into designing and building the database. And I kind of want to talk a little bit about that, just about the design. And that sort of thing. So, and just so you know, I did forget to take a snapshot of the server when it was finished with part 1. So my server is actually done, but we'll try to mimic it the best we can to make it look like yours. All right, so the first thing you're going to do is create the database. And like we've talked about, we're going to use Postgres. So it'll be a little bit different than what you're used to seeing in the class, but it's not going to be too bad. So like I said, mine's actually already created. So, you know, I'm not going to actually demo this, but I did make sure that these are all pretty straightforward. And I think a few people have already made it through this point. So but just a real quick talk about what you're going to do. So in Postgres, there's actually a user. So just like in Fedora, how you may have seen at times that we switched to the Oracle user. And that's because that user has special privileges with that software. Well, this is the same thing. When we installed Postgres in part 1, we created a user. They created a user for us called Postgres. And so we connect to that user. And then we can use some certain commands that make it a little easier, that do a few things. So we use a command create DB, and we create a database called course catalog. And then we also create a user called catalog app. And then we actually log in. So just like in the class, we use SQL Plus to connect to Oracle, we use a program called pSQL. So we connect to pSQL, we connect to our course catalog database. And Marie so she said question on that first attempt to connect. Go ahead and ask a question.
So right there it says pSQL course catalog course app. Should that be catalog app? Right here where it says now attempt to connect with our new info.
Yes, I'm glad.
Okay.
Yep. In fact, let's just go fix that real quick. Yeah, that got to be a tongue twister as I was writing these instructions. I found I was constantly fighting the urge to type that. So good catch. Okay, so yeah, we create our catalog at our course catalog database. We create the user catalog app. And I guess just as an explanation, we create a specific user that's just for that application. So normally, like what I do is I have my own user, and I'm a super user on most of my servers. But if you were like a developer over one specific one, but most of the time you're probably going to be admin privileges, kind of see more than one database. And so whenever I create an application, rather than just use my credentials, I create a user specific for that app, because that way if that user ever gets compromised, like that password, you know, they only have access to the one database, not multiple. And it's nice because it just keeps things cleaner. So I create a user, and I usually do it the name of the app with app afterwards. So we call it catalog app. Then we connect to the database, the PSQL utility, to Postgres, and then we connect to our database. And then we change our user's password. So, and the reason we do this is because by default, Postgres allows you to log in using the Linux users. So just like on Fedora, how we already had that student user or whatever, let's say you had a server and you already had Linux users, they could all have their own credentials kind of there. But we want to log in with a password, not by doing some pre-authentication with Linux. So we have to set a password in the database. So we say alter user catalog app with password, and then you would put some secure password here. In all of my examples, I use School Rocks right here, just so you're aware. If you wanted to do School Rocks, then you wouldn't have to change things later on, but it works either way. And then finally, we grant the privileges on that database to our app, so it can pretty much do whatever it needs to, because we're going to need it to create records, we're going to need it to delete records, and all this other kind of stuff. Then when you're done, you'll exit the PSQL utility. Then you'll exit out of the Postgres user, and then you will exit out of the root user. And then you'll try to connect with our new user and our new user, right? So the way this works is you say PSQL, and then you put in the name of the database that you want to connect to, and then the name of the user. Now, like it says here, you should get an error here, and that's because we haven't set configuration to allow people to just log in. It's a security thing. Because the way Postgres comes out of the box is that you can only log in if you're already logged into the server, which is pretty tight security, because that way you can't have people log in from China, you know, wherever, unless they already have compromised your server. So to do that, what we do is we edit this config file. Now, Linux servers is all about editing a similar config file, something very similar. So this is really good practice. So we're going to edit this config file, and in there you'll see a line that says local all peer, and it's down towards the bottom. And I took a screenshot here and highlighted it, and you're going to change peer on the last little bit to MD5. And at the end of the day, it should look like that line there that's highlighted. And then you're going to save and exit. Now, if there's someone who's already gotten to this point, and I think there have been, have you guys been using Nano? Nano is the way that you can edit files in command line, and it's just a little bit weird because you'll make your edits or whatever, and then to save, you do Control O, and then to exit, you do Control X. Has that been any too big of a trouble for you guys, or has that been okay? I was just curious, because in the first part, I really tried to like kind of explain what the Control O, Control X did, but then I'm hoping that by now it's becoming more familiar, so I just kind of put it there as a reference. Now this is the part that a few people that have made it this far found that I had forgotten. So we make these changes to the file, we save them, and those changes won't take effect until we either reload or restart the service. Now, in Linux, a lot of things will work on a reload. So you could say sudo service PostgreSQL reload. But just to be on the safe side, now a lot of people use reload if you're, you know, let's say your website's up and a lot of people are using it. If you restart it, it's not going to kick people out, but it could cause some issues depending, like, you know, you can imagine if Google decided to restart their services while you were in the middle of a type in a paper or something on Google Drive and they didn't have the autosave feature. And so anyways, I use restart just because we don't have people relying on this. So then someone in the chat, looks like a couple of people had an issue with copy and pasting. And I don't know if it's a Windows thing. I do know that you have to use Control-Shift-V. When you're pasting in a terminal, you have to use Control-Shift-V, and maybe that didn't work in whatever tool you were using. I don't know. Okay, they said it didn't work but it looks like Putty did work. So you could try Putty. Ooh, that's harsh in the virtual machine. Yeah, that's interesting. And I do think that in the if you get Ubuntu from the Microsoft Store, there is somewhere in the menu, like if you right click on the title bar or something, it does give you a copy paste option. I remember that somewhere. I believe somewhere in there. I remember when I was goofing around with it at one point, there was something, and yeah, you can try Googling it, and maybe there's something. I'm pretty sure there was something. I have a hard time thinking they'd leave that out. But anyways, once you restart Postgres, the PostgreSQL service, then you should be able to then log in with your credentials. All right, now this is another place where I had some issues. So just so you know, you can find all of this code, at least for the Flask stuff, you can find all this code on my GitHub. So here's a link to my GitHub. I'm going to open this in a new tab here. But the important one is this. This is our database script. This is what's going to create our database, as well as create some initial data, so we actually have something to look at. So we're going to come back and talk about this in a minute. But you can go there and check it out, or you can download it directly to your server using the wget command. So I put a copy of this file available to where it could download, and you can just download that file directly using wget. And then you can load it, you can log back into pSQL, and then you can execute it using the /i and giving the name of the file, and it should just run. And in fact, let's try that right now. So let's go to var ww. All right, so here I am. I have my course catalog init.sql file. So let's log in here. So we're gonna go pSQL, course catalog, and then our user is catalog app. And then I'm gonna type in my password, which is school rocks for me. We're gonna do /i course catalog init.sql. And it should run just like that. And you'll notice that it, just like what we've done before, it drops the tables, it creates a table and does some inserts. And then I put this here because this is kind of like a big part, right? I want you to kind of stop and think, because I did this so it would be quick, right? Because this is more about seeing how this all ties together. You know, I wish that there was more time and I would let you actually design the database, but obviously you're not expected to know Python, so then it's kind of like this big thing. So anyways, I created it for you, but I do want you to review the design and kind of understand it, because you'll notice that it's extremely similar to what we've been doing. So here you'll notice that we have this system user table, and I'll be honest right now in the way that this is written, because I kind of ran out of time. So limited functionality, we have this system user table, but we're not actually using it yet, but it is there. So we have the system user and we do an insert into there. Now, one thing I want to point out is in Postgres, you'll notice that our primary key has this data type of serial. And what a serial is it's a number with an automatic sequence tied to it. So what's nice is when I say create system user and I have system user ID serial, it not only creates the table with all that, and, you know, here we define our primary key, but it also in the back end, without me even saying anything, creates our sequence. So I could actually go and do our sequence stuff on the system user, and then they self-name them, so I'd have to look and see what its name is, but it creates the sequence for us. And I guess just to kind of explain the differences, so Postgres is very much like Oracle. I would say that it is the open source Oracle equivalent. It has a lot of the same features. It's right up there functionality wise with Oracle and Microsoft SQL Server. But the best part of it is, like in this case, we're able to do this because it's free and open source. And when I say free, I mean the free is in beer. So we can get it. There's no licensing fees attached. It does have a software license, but we don't have to pay for it. And so it allows us to develop, especially, as students or as startups and all that, or even as large businesses, you can save a trundle of money using Postgres. And because it has all the features, you're not really sacrificing anything. Versus something like MySQL, there is some limited functionality. So that's why in this tutorial, we are using Postgres, because me and a lot of colleagues, in fact, I had a big discussion on LinkedIn with Michael McLaughlin and many other of my classmates from college. We were in there chatting, talking about, the various database systems, and Postgres, in comparison to some of the others, are somewhat new to the scene. It's newer to the scene. Don't get me wrong. It's not like it's it's kind of the new kid on the block, but it's fleshed out. It's not like a sketchy thing. And, we were all, people were speculating what they thought kind of not necessarily the best, but the one that's kind of like people's go-to. And Postgres was, I wrote a little, my opinion on Postgres, and everyone seemed to concur that it is kind of going to be the one to be on, essentially. So as you guys, when you're looking out at your jobs, you're going to be, Postgres is a great thing to know. If we put this script into the developer tool, will it create the database in our Oracle School Student instance? No, and the reason being is because there are a few things that are Postgres specific, like this serial data type. I do not believe Oracle has a serial data type, so it would throw some errors. But you could change a couple of things and make it work. So it would be very close. In fact, I think you just have to change a couple of the data types, add sequences manually, and then change int to number. And then down here where we do multiple line inserts, you'd have to split all those out. Like I said, there's some really cool things about Postgres. And then someone else said, we use Postgres at my office, and we are a Fortune 500, 120,000 people international company. So yeah, there you can see it scales great. It's perfect. Here we are using it for a very small specific thing, and it works all the way up to massive, massive systems. So it's a great tool, and it's free and open source, which is awesome. So anyways, sorry, rant complete. That went down a rat hole, but let's keep talking about our database here. So we have our system user, and then this is where we actually kind of start to get into the meat of this, and we're going to talk a little bit about this, because this is where, when you guys are organizing data and designing data structures, this is where you'll have to make big decisions, and this is where it's really nice to be thinking ahead. You have to be a great planner to be able to do this kind of stuff and try to exhaust avenues, essentially. So, and understand business logic. That's the other thing, is you need to make sure you understand business logic. So here we have a catalog year. And if we look at this data, we can kind of see what it's going to do. So we have our primary key. We have a name. We have an end year. And then we specify whether it's active or not. So basically all this is it's going to have a name, an end year, and an active. And so basically kind of what this is, basically it's just storing years. All right, so 2020, 2021, and and basically like what this is going to be is the name would be something like 1920. The end year being that the end of the year that the school year ends would be 2020. Right, so then you give it a name. Basically, it's just to store school years, though. So like given our specific term, like if we were doing this for BYU Idaho, we would create a catalog year just like this for 1920, and the end year, the year, when does the school year end? Well, it ends in 2020. And then we set it to active because it's our only one. The default is 1, so we could have just left that off if we wanted, but we have it there. And then we have a school. So we actually built this so it could handle multiple schools. And the reason being is because I slightly killed 2 birds with 1 stone on this project. So I'm actually planning on using this in our school. So, and I'll make it open source. So if any other school wants to use it, they're more than welcome to. But basically, we'll be able to handle multiple schools. So let's say in your city, or in your county, there's 10 high schools or however many. You can put all your high schools in here and handle all their various data. Right? So that's pretty straightforward. Nothing too crazy there. That would kind of be similar regardless of your design. And then we have credit type here. And a credit type is our math, English, science, social studies, vocational fine arts, physical education, and elective. And basically, it's super simple. It's just a name and a code. Now, I want to pose the question, and feel free. There's no wrong answers because we'll talk about it. I mean, there is a right answer, but feel free to get the wrong answer. That's part of the fun. If we wanted to tie credit type to a school, let's say we said, okay, schools, or let's say in your district or wherever, college, whatever, let's say the school had the ability to have their own credit types. So it was managed at the school level, not the district level. What column would we put into credit type if we wanted to tie credit types to schools? Don't overthink it because it's pretty easy. Yeah, there we go. School ID. So that's kind of where you have to start thinking, right? Because all it takes is 1 column in a table to make that big difference in business logic. So in this case, credit type is defined across the whole system, right? Which my guess would probably be the majority of cases. In fact, I know that here in Wyoming, credit types are really defined at the state level. So, but this does let you have some fine-grained control at the district level. But we could further give more control and options to schools by tying it to the school. But in this case, we didn't. So we're controlling this from the district level. So then we have our name and code. So nice and easy. Is there a tool that you can use to see the schema of this database? There are lots of tools. In fact, I don't have my server set up to where I can log in remotely, but there is PostgreSQL hide web. So there's a PG admin right here. Okay. And I think that this has the ability to generate relational diagrams, but you could actually install this in your virtual machine and it will be on a website. So then you can connect it up and run it. It's PG admin. I've never actually done it. I've always been tempted to. Here's an online demo. Let's take a look. Well, let's okay. Well, we'll try again some other time, but I'm pretty sure that this will let you do that. Or if you set it up to connect remotely, an application like dbeaver will build the relationship diagrams for you. All right, so there's our credit type. Now we're going to start diving really into the meat of this whole thing. So now we have a catalog, and a catalog is just, we have our primary key, but then we have a school. So we're tying it to a school, and we're tying it to a year. So we're going to have a catalog for every year because courses change pretty much on a yearly basis, right? That's kind of the business logic here is courses change on a yearly basis. So our catalog is going to change yearly. So every year we're going to have a new catalog, and the catalog belongs to a school because we're tying it to the school there. And then just real quick to point out, you can see that how we build our primary key and foreign key constraints are identical between Oracle and Postgres. So here you can see that I insert into catalog, and I build a catalog for a school. Here's my subquery to get the school, and the school is Shire High School, by the way. So we get the school, it's Shire High School, and we call the catalog Shire High School 1920. All right, then we create a table for courses, and this is where really the bulk of the data will sit. Because, you know, for every catalog, for every one catalog, there'll probably be like 200 courses. So this is where the bulk of our data is going to sit. And in here, so because the bulk of our data, that's kind of where the most columns are. But you'll notice that here we have our course ID, and then we have catalog ID. Now you'll notice that we don't have school ID in here, and that's because catalog is tied to the school. So there's really no reason to duplicate that data because it's already inheriting from school. So we have a course is tied to a catalog. We have a course number, so like CIT225, a name, database development and design, a description where you can put HTML content to display or anything like that. I did put a thing for a video link because that's probably what our school district is actually going to use. The number of credits, the credit type, and whether it is active or not. So pretty basic, right? Nothing too crazy. And then we do an insert into course for CS 101 and Introduction to Web Development, and then the description. And like I said, I ran out of time, so a lot of this data we're not actually using yet in the actual web application, but I'm going to be fleshing it out. So it will be coming. I'm just not there now, which is okay because it's actually going to keep it nice and simple for those of you who want to reverse engineer a little bit. But anyways, there is our database. So you can kind of see how that works. It's nice and easy. We build it all in one script. So when we ran that, it just did it for us. So let's try to continue on. Let's quit this, and we're out. All right, and then this step, preparing for the Python integration, we just have to install one more package to make it work, to get a few of the stuff to make it work with Flask. And that's just the development packages that come with all the stuff to make it work the way that we're going to. All right, any questions up to this point? Looking pretty quiet. Okay, if you come up with a question, feel free to put it in chat. Otherwise, we will try to continue onward. Now, we're going to look at, so that was step 4, and now we're on the last step, which is step 5. And so basically at this point, we have our database, so everything's set up, but now we just need to actually build the web application. And like I promised, you don't have to write any Python. You do have to edit 2 files, all right, just to put in your username and password for your database. So it's relatively pretty simple. I've written all the other code, and it should just work for you. And we're gonna test that theory here in just a minute. And I actually already tested it once because I kind of built it, then deleted it after I saved it and kind of set it up. So like I talked about, all these files are on Git. And I would say if you don't know Git in some basic form, I would really recommend you check it out. because it's so handy. In fact, so real quick, I'll go on just like a real quick rant here. So if I look at this Git repository, what's nice about Git is it's more than just a place to store your code, but it stores every change you've ever made. So for example, if we look at my commit history, I can actually go back in time and see every little change that I did, at least every commit that I did. So I'll do a lot of work and then I'll commit, or what a lot of the bigger places do is they'll fix one little thing. So like, let's say that the word is misspelled. They'll fix the word and do a commit. Every little task is a commit. And that way they can undo pretty much anything. So this is really handy, especially if you're working with code, and it's especially handy if you work across computers. So what I do, because a lot of time I have a little lap desk thing made out of bamboo that you can get on Amazon for like 13 bucks. Because I really like to watch movies and TV with my wife and still work. And so what I do is I will be on my desktop here and I will be writing code. And when it's time for the show to start, I commit it and put it into a branch. And a branch is kind of like different places you can store stuff. And so I have like Tanner update. Master is where the final product is. And then I have Tanner update, and that's where I kind of store my work in progress stuff. And so when I'm working, and then when I finish all of the commits that I want, I can just commit it to master or merge it with master, and then it becomes in place. So anyways, if you don't know Git, check it out. It's pretty handy stuff. But anyways, we're going to use my Git repository to actually pull this code down. And what's cool is that you'll be able
Hey,
to.
Brother Crook.
Yeah.
There's a message in the chat about an error, some errors when she
It
ran it.
looks like she said ignore that at the end.
My bad. Sorry. Excuse me.
Yep, you're good. So anyways, we're going to use my Git repository to pull all that code down to your server. So what we're going to do, the first thing we're going to do is move. Let's see. Oh, and let's see. Let me hurry and fix this while we're here. I forgot to put formatting around this to make it look like code. All right, that'll be better. So what we're going to do is we are going to back up what we currently have. So if we go to our var www app directory, and in this point it doesn't matter because we use absolute path, but if we look in here, we have you'll see an app. And so I have this extra app.back. In fact, let's move app.back to my home directory. There we go. So yours will look something like this, right? Because in part one, we set up app with kind of like this bare bones Flask, right? It just works. And all it does is it says hello with your name. And the reason I did that is because at that point, you guys could use that as a blank slate to build whatever Flask app you wanted. And to keep that, because I kind of want you guys to keep that in case you just like want to start building your own, what we're going to do is we're going to save that. So we're going to move our app directory and we're going to call it app.back. So let's just run this in here. Just grab it, copy. And so now if I look in here, it's going to say app.back. Now at this point, your server is going to crash and burn if we try to go to it because we just moved all the files where it thought it was going to be. And that's fine because we're going to replace those. So now we're going to make sure we're in our var www app directory, which we are, var www app. And then we're going to clone that repository. And cloning means we're just going to take and download all those files. It'll do something like that. And then if we look in there, we now have our app.back, but now we have this Flask lamp directory. but we want to call that app because that's kind of what we expect it to be. So we're going to say move flask-lamp to app. And we use the move command to rename things. It's kind of weird, but you kind of just move it and rename it at the same time. So now we have app and app.back. App.back is our plain bare bones if we were going to leave it stock or empty per se. And now app has all the code that I've written to make it work. So if we go into app now, because we moved it, and the virtual, and we kind of built it. If you guys remember when we had the venv, the Python virtual environment, those don't really sync well across computers. Like in this case, you don't really ever want to upload your Python virtual environment and let someone else download it because it doesn't usually work all that well. And so what we do is we have you create your own. So we're going to go back into our app folder, and you'll notice that we're missing a venv file. And so we're going to create one of those real quick. So we're going to say python 3-m venv. And now we have our Python virtual environment. But then what we need to do is we need to install all of our requirements, because in building the application, we have like the software that lets it talk to Postgres. We have Flask itself is just a Python package. So we're going to get all that. And to do that, we first activate our container so it knows that that's where we want it to be. So we go source, then bin activate. Wow, that's a tongue twister. And you know when you're inside of there because it'll put this right here. And that means, oh, you're in your virtual environment. And then we can install the list of requirements, because I've put them in a nice little list here that will install for us, and it's called requirements.txt. And so we're going to say pip3 install -r requirements.txt. And that will just take and install all of our requirements. Now, what we need to do is, if we were to try loading it now, it would still have an error, and that's because our database is not connected. Technically, it's all there. If you use the same credentials as me, it actually would just connect, but I'm going to show you how to edit those files. So to edit these files, it only takes two files is all. So the first file we're going to edit is in models connection.py, and that's if all paths are relative, you being in var ww app. So, and that's where we're at. If you're in the, so if we type pwd, you'll notice that that's where we're at. So now let's, so we're going to type in nano models connection.py. Now inside here, we're going to look for the line that talks about our engine is equal to a create engine. So right here, and you're going to change two things. So this is our username, and then it has a colon, and then we have our password. And those are the only two things you're going to need to change. So mine are here. It's all set up ready for me to go. But if you had a different password, you just got to change that right there if you use the same username. Just to explain what this is, basically it's saying, look, we're connecting to Postgres using the package psycho pg2, which is just a Python package. And then it's basically a URL. So it's basically telling it where it's going to go. So you'll notice that we log into the catalog app user using this password at. So now we're saying, where is the database at? Well, it's at localhost, meaning it's on the same computer. And then we do a / and then the name of the database. Right, so you change those, you hit Control-O, Control-X, and it's saved. And then the next one we edit is our app.py, and app.py is kind of like our main file. It's the one that runs first. So, and it's in our normal directory, so we just say nano app.py. And then down here where it says SQL Alchemy database URI. And you'll notice that we kind of put you guys built a similar file to this before, but I have added quite a bit to it, as you'll notice. And you're going to do almost the same thing. So this time, though, it doesn't say psycho PG2. So you'll change your username if it needs to be changed. And then here's our password. And then localhost / course catalog. Now, this is a public Git repository. So normally you wouldn't put a live production database and password in there. Obviously, probably a pretty good idea. But that's why we have these security things in practice. So right now, this catalog app can only be logged into from the server. So if your database app isn't the same as your username for your Linux server or anything like that, you're actually, it's not good security, but you're going to be safe. But I pushed it because I don't ever plan on using this password for anything. But anyways, almost the same thing. You just have your URL to connect to your database. The only difference is we don't have that plus psycho PG2. And then when you're done there, you're going to save that. And now we're ready to go. So all we have to do now is restart Apache. Because anytime you make a change in Flask, you have to restart Apache. So sudo service Apache 2 restart. And that's really just to kind of clear the caches, to be honest. So now let's try to reload this and cross our fingers, and there we go. So this is actually our Flask app running. And those of you familiar with web development, this is actually using a Bootstrap. And so here we can kind of see it. And so this kind of explains it. So like I said, it doesn't have a whole lot of functionality, but it does work. So let's take a look at what it's doing here. So as we talked about, we kind of organized our catalog by schools. So let's click on schools. And here we have our Shire High School. And this is pulling directly from the databases we'll talk about here in a minute. So let's view the course catalogs for Shire High School. And so now, and you'll notice the URL up here is changing. So up here we have school all, and we say view, it goes school 1. Well, this 1 is our primary key for school. So when it says school 1, and you'll notice once you start doing this, you'll notice that when you're going to the websites, you'll be able to pick out some information. In fact, the church actually uses a similar URL scheme, but they use unit numbers. So like if you go to the map of where to find meeting houses, you can actually find the ward unit numbers from the URL. But anyways, here's our course catalog. So the 1920 high school catalog, let's view it. And here is our course. Now, normally you wouldn't have a big add course button for a public facing website, but I wanted to show you how you could actually use this to do various things. And so and right now this view button doesn't do anything, by the way, it's just there. But let's click add course and let's build a new one. So let's build CIT225. So we're going to say CIT225 database develop design and development. Credits, it's 3 credits and it is vocational, let's say. How do you, we'll say the best class in the world, psych. All right, and now what we're going to do is we're going to hit save, and it's going to take us back here, and all of a sudden now we have CIT225 database design and development, right? And so this is a real simple example because that's pretty much all it does at this point, right? It doesn't do too much. But what's really cool is you can take kind of this basic, because all this code's in there if you really want to go take a look at it. But you can see how you could build full systems using just a similar thing, right? And it's really, really pretty cool. Because really what you would probably do is you would have this without like the add course button. But then you could build an admin side to where, someone could add courses themselves. Or like what I'm planning on doing is I'll actually make it to where you can upload a CSV file with all the data in there. So let's say, you have all your courses already in a system. Well, it'll just you can just export that data using SQL into a CSV file and upload it into this system, and then it will be a navigatable course catalog. Now, obviously, there's a lot you could do to make it cleaner. I was just kind of going for a demo purpose here. I'm planning on cleaning it up quite a bit. Like, for example, I probably wouldn't use big giant boxes for the courses, because by the time you get 200 of them in there, you're going to be scrolling a lot. And it's going to be a pain. So I'd actually put those in a data table where you could search, and stuff like that, which is all possible. But anyways, this is the end product for the most part. And hopefully it's gives you kind of an idea of what can be done. And what's really cool is, it's all interacting with that database. That's kind of been the whole point of this class, is to make stuff like this possible. And because sometimes databases seem just a little bit more on the dry side of the things. But really, if you think about most of the software that you use every day, it's almost all of it data driven. And any data-driven piece of software is going to be using some sort of database. And so that's kind of where my drive comes in. My passion is I love data-driven products. And as a result, I love databases. And that's why I do a lot of data analytics and all that stuff. Because once you build systems like this, then you can start building in data analytics, to say, oh, how many times did a student click on a certain course? What's the most popular and all that kind of stuff. As far as initial view, what can we do to increase, interest in a certain course or whatever? There's lots of possibilities, but anyways, that's kind of the gist of the lab. Does anyone have any questions? Comments, concerns? If you're not necessarily, if you're not in the right directory, you just need to use the CD command and get there. So like if you're in it looks like you're here, rww app, all you have to do is do CD app, and then you'll be in the right directory.
Do I need to do that when I'm in the getting the project files part?
No, you'll want to be in var ww app when you're getting the project files.
Okay. So when I'm doing the building Python, I just need to make sure I move to that directory.
Yep.
Okay.
Yep. Good question.
Well, I have one more question.
Okay. Yep.
So those errors that I stuck in before that I said ignore, the first time I run the thing, there are no tables to drop. So I'm getting that, and then I'm getting the inserts. Is that supposed to be right?
Yep. Yep. Because it'll try to drop the tables that don't exist. So,
right. So
that's why
there was nothing to drop.
Yep. Correct. Yep. But they should create it, and I'll put a note of that in the instructions. So that way it's not confusing. But anyways, I hope this is kind of cool for you guys, just to kind of at least see something, usable. And let's actually see. Oh, and one thing I did want to point out. So how we're always talking about the common lookup table? Well, this is where the common lookup type tables are nice. Now, I don't have a common lookup table, but it's a similar thing. So you'll notice that we have like these. Now, we could easily just, on the course, type in the name of the credit. But then you run into all sorts of issues as far as like, oh, how did they spell English? Did they use all capitals? Did they use lower, all that kind of stuff. And so that's why we have that common lookup table for like Visa, homework, Blu-ray, DVD, and all that kind of stuff. And it's really to make our data integrity solid, but it's a great way to make drop downs. So for example, real quick, spur of the fly, let's run PSQL course catalog. catalog app. Let's just log in here. All right. So if I do select everything from credit type, here's my things. Well, let's say all of a sudden you're going to start offering some, and am I missing anything here? Math, English, and social studies, vocational, fine arts, physical. I don't know if I'm missing anything, but you can add something super easy to the list. It's just a simple insert statement. And once you do that insert statement, so let's just add one. So we're going to say insert into credit type. And we're going to insert into name code. And we're going to do test, or what, let's see, what's a, let's call it capstone. All right, and so now all of a sudden, I mean, obviously with a page refresh, I have capstone. And so what's nice is you can build a lot of stuff in your database that makes it so you never have to rewrite any web code, which is really nice. Anyways, I guess let's quick and see where people are at as far as some options, because we did quite a bit of talking about the finals last week. So we have a couple options here. I could try to answer questions about various final things around the study guide. I can't give away too much about test type stuff, especially where they're open right now. So we could either do that, talk about the test, or we could dive into this and I could show you a little bit of how the Flask works. Flask works in case you want to reverse engineer it just a little bit. So if you guys want to throw in your preference in the chat, if you want to go over the study guide some more, or look at lab 14. Okay, there's one for test. One for Flask. We're 50-50 right now. Need more input. And I guess, yeah, if you guys want to real quick state your preference, I'll wait about like 15 more seconds. Because, yeah, that's what I was about to say is we could, if there's only a couple people curious about some test stuff, we can real quick answer those, make sure everyone's good, and then we can hit Flask for the rest of the time, which is kind of what it's looking like, or it looks like a lot of people either don't care or are too afraid to say otherwise. Okay, that'll be good. Okay, let's do that. So real quick, if you have a question about the test, we'll start with, in the order of the chat who said test. And I can't tell who you would be from your
That's
name.
Shannon Smore.
Okay.
That's my last name, Shannon Moore. My question was just, like, as I went through so I've done the vocabulary test, but on the other test, I'm blanking on what to ask. I was just thinking, it just looked like it was looking for very specific, like, language explaining. Like, it's not enough to just explain it. You have to use like certain terminology. Does that matter or not? And I may have been asking the right thing.
Are you talking for the vocabulary exam or
No, the other
query?
one.
So the query exam, what it's basically going to do is it's going to show you some sort of statement or query. And basically, and these are all basically almost, I doubt they're taken from certification exams, but they're structured identical to certification exams. And basically what it's expecting you to do in a certification exam is be able to per se execute the query in your head. And what that means is you have a fine understanding of SQL and you can see a statement and know exactly what's going to happen. In this test, though, where it's open book, it's almost like the way I see it in this case, it's you should, given the time constraints, it's more read it and really analyze it. Take the time, analyze the statement, and then I would say go and do research to back up what your gut instinct essentially. Um, that's kind of what I would do, and basically all it's going to ask is does it run, yes or no, and then it's going to have a third option with a drop down that says is it going, like, basically what happens, does it, so if you said it fails, then your other option would be it fails because of X or it fails because of Y. Now, because it's multiple choice, depending on whether it runs or not, will determine, will really narrow down your options for the second question. So what I would say, yep. So it's just like the practice with the drop-down choices. So what I would say is I would first look and try to find anything that would make it not run. And when I say not run, it would not execute. It would throw an error. And then what I would do is from there, you'll be able to cross off some of the answers, the possibilities, and then you'll be able to look at those and then make a good guess. Now, really, from what I've seen those tests, and from I took the certification exam as well, which is identical. I actually had to take it for my master's degree. But when you take that certification exam, what I did is I would follow that. But it's really an exercise in attention to detail, because a lot of those questions are going to try to get you hung up on something. And so, or they're going to try to almost trick you. In fact, we saw that last week because I was going over the study guide, and obviously it's kind of hard to focus while you're trying to talk and stuff. But just like that, your first check is, your immediate reaction is you want to go to what is this going to do? And so you look at the select statement. Oh, it returns first and last name with a space in between as a string. So that's going to be your first instinct. But like I said, what I would do is I would first analyze it and see if you can find anything that's going to make it not run. Pretend that you're grading someone for that first portion, because once you analyze so in your certification test, the timing, you actually only have slightly over a minute per question. So you actually have to be really fast in the certification exam. For this one, you get more time. But in the certification exam, you had to be fast. So what I would do is I would go through and immediately look over at very detailed to see if it would run or not. Because like I said, if you find an error, it's almost like a freebie. So most of the ones that I looked at I was sitting there hoping like, oh, please let there be an error. Please let there be an error. Because then once you find where that error is, you can immediately stop looking at it for the most part and answer the question. So that's what I would say to do, is just kind of go over, is it going to run, yes or no? Find the error. If you can't find an error, then analyze the query. And at that point, you kind of maybe already have an understanding just from looking for the error. You'll be able to look at it and kind of see. For that one, I will say, keep a list of functions handy, because those will pop up, and you'll want to be able to know what they do. Does that help at all? Kind of went off there for a little bit, but I hope that helps with the question. But okay, perfect. But yeah, it should be formatted just like the practice exam.
So I have a quick question,
Uh-huh.
if that's okay.
Yep.
So on both final, there was 2 practice final exams, right?
Uh-huh.
And on one of them, it has select hello world, da 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 da, and select hello world. One of them has single quotes and one has double quotes. But on the other one, they're both single quotes, and yet they give you both different answers. Will there be an opportunity if we get something that's like that we disagree with to say something or not?
Yes. And hopefully there's fewer and fewer of those. Because I've been teaching this class for about 5 years, and about my second year in, they rewrote the tests. And so basically for 3 years, I've been slowly reporting, people have been reporting test fixes throughout. So hopefully it's there. So if you come across something like that, the only thing that I would ask is, because I do get, and because when I first started, and I didn't really like give this requirement, but my one requirement is before you send something like that. I mean, if it's blatant, like weird thing, like there was one time the image of the query just didn't even show up. So, that's one thing. But I also, the first year I got just flooded with, this question I believe is wrong. This question I believe is wrong. And most of them were right. And so I spent a lot of time going over, and the tests now actually will tell you why. When you actually take the test, it'll actually show you why, I believe. That was one of the things that they added in the rewrite. So the one thing that I would ask is, before you send that request, do your due diligence and just make sure that, ideally what would be nice
Absolutely.
is to maybe even come up with, what the correct answers should be. Get real detailed on it. So.
Well, and they're on these 2, they're identical, except for one has the double quotes and one has single quotes, which is that one is this double quotes gives you a fails because of a syntax error.
Right.
But if they're both single quotes, it doesn't fail.
Yeah. Yeah. And that can be common in those practice ones, because it's probably just, the images probably look extremely alike for the query.
No, I printed them out. They're the same.
No. I mean, like, they're probably the same, but whoever built the test probably just selected the wrong
Missed
one.
it. Okay.
So the lesson 14 and all the finals are due Thursday the 9th by midnight Mountain Time. Is that right?
Correct.
Okay.
And so I can give a lot of leeway. So those deadlines are more encouragements. But like, if something comes up, just talk to me. If you need some more time, just shoot me a message and I can work with you, because this semester's been crazy. So yeah. And that's more just because that's when the semester officially ends, but the university did let us know that we have some leeway on all that, given the.
Well, and the vocab test said it was 50 questions, but it was only 25 too.
Yeah,
so.
and it because on the page that someone wrote, it says 50. When you actually go to take the test, like, because it pulls out of the actual setup, it says 25. But I already submitted a fix for that as well, so next semester, hopefully. Good questions. Any more questions about the tests? Okay. If you think of one, feel free to throw it in chat. Until then, let's real quick, let's dive into a little bit of this stuff we got going on here. So let's go into our app directory. So Flask, what it is it's a Python package like we kind of talked about, and it's our middleware. It's our framework. And what's really nice about having a framework is it takes a lot of the work out of it for you. So one thing I really wanted to talk about, because this is huge, it changed the way that I built software. And that is, so in here on the instructions, you'll notice that we talk a lot about SQL Alchemy. And what basically that does is it's a way for us to interact with our database without having to write all this boilerplate code. And so let me explain that a little bit. So the first time I wrote an app, a web application, is kind of before Flask was kind of a thing. You had to write all your Python classes from scratch. And what I mean by Python class is you have to basically rebuild your tables, but in Python. And beyond that, then you had to build functions to say, oh, you know, what happens if I want to save a new course in my database? Well, you have to build a function that connected to your database, took all the data that you wanted, and then converted it to the right, you know, data type, and then it put it in the actual database. You know, lots of boilerplate code. Well, so what SQL Alchemy does is it kind of handles all a lot of that boilerplate for you. Specifically, what SQL Alchemy does is it handles like the inserts, the queries, the updates, and all that kind of stuff. So we're going to talk a little bit about SQL Alchemy here in a minute, but a big part of SQL Alchemy is that the classes, because to obviously use something like that, we have to define our data in Python. So it knows that, you know, oh, what is a course? What does a course have? How do we access that data in our Python? Well, in here, I actually have a little thing to kind of talk about it because I didn't want to get over confuse you. But in here, I have another thing that talks about how we can generate Python objects from an existing database. So what I did, just like you guys saw, we have our database script, our course catalog init.sql. So I wrote this from scratch, designed the data, and I executed it. Database exists, because that's kind of what I like to do. And then what I do is I use a package called SQL a code gen. And basically what it does is it generates all of our Python classes for us from the database. So you'll notice that we use this similar URL structure. So I did PostgreSQL catalog app school rocks and ran this command. And I specified the out file as models.py. So if we actually go into our project here, we can go into models and then models.py, and this is the file it generated. So I didn't have to write any of this code. It basically it looked at my database and it built it all for me. So we look at this and it built all my Python classes for me, which you can see isn't too much, but in a bigger piece of software, this can save you out like a year of development, right? So it builds all of our tables, but in Python. So you'll notice, like for a school, our school ID, it defines a column and an integer, you know, and it has a lot of boilerplate code running in the background that someone's already written for us, but it kind of takes care of all of it for us. And here you can see our sequence. So like for school ID, the server default is next val, our next value in our sequence. And what's the sequence? School ID sequence, right? So basically it's pulling the next val. And the Python actually kind of knows to do that. So then we put that file in here in our project. And then if we were to go to like, let's look at where we actually load the schools. So here's our school.all. Now you'll notice up here we have from models.models, and that's the file we just looked at, models.py. We import a school and a catalog. So we import our data, our classes. And then to list all the schools, all I have to do is say schools are equal to a database session dot query, and I'm going to query all the schools. And then I can render a template or render an HTML page, and I pass it schools. So let's take a look at this one real quick. So here's our function. The way Flask works is you define a route. And by route, you know, it's basically the URL. So if I were to take this, basically the route is the host name or the domain name. So in this case, 10.0.0.60. And we're going to put that route in there. And it's going to execute this Python when we go to that route. So it knows, oh, if someone goes to, you know, school all, then run this function. And so from this function, it's going to get the list of schools from the database, and it's going to store them in an array called schools. Then it's going to return a render template. So basically it's going to say, look, render this template. And so then if we were to go look at this template, school, allschools.html, right? That's the name of our file, and it's just HTML file. And we're going to pass it some data, and that's the important part. So we pass it the schools that we just downloaded from our data, or that we just got from our database. So let's go take a look at that HTML file, and those are in your templates by default. So, and then if we remember, it was school, all schools. So this is where it's going to look. And so then here we have some stuff. Now we've kind of pre-built all this. So you notice this extends base.html. And that means that we don't have to write, if we look at the demo, this header where it says course catalog, homeschool, all that is all written in one place. So we don't have to change that on every page. We could change that all in one spot. But where we get in here, you'll notice we have access to that schools variable that we sent over. So then we can kind of run Python inside of this HTML. So when it hits here, for school in schools. So we're going to loop. This is a for loop, right? We're going to loop through all the schools. And for every school, we're going to print out this HTML. And in this case, we are going to get the school.name. And we're going to say view the school's abbreviation, course catalogs. And if we look at this, you'll notice it kind of just puts it right in there for us. And then the button is an HTML, is a link, and we run a function. Now, this is probably one of the best parts, because one of my biggest annoyances, even with something like WordPress, is that if you change certain things, things quit working, because URLs are mostly hard-coded. But what this does is it actually looks and it says, look, get the URL for this function. So the school, if we go, let's load up in another page here real quick so we can look at two at the same time. So in our school class, right, our school view, this is, and they call it a blueprint. And then it's going to look for the function school catalogs. Oh, and here's our function school catalogs. Now here's kind of where the magic happens, is it's expecting a school ID to be passed as a get parameter in the URL. Because that's kind of how it gets its data. That's how it knows what school we're on, right? Is because if I change this to school 1, it's going to take us to the Shire's school page. And so we have to pass it that 1. And so, but we want to do that dynamically. But because we already have the school in there and each one of these buttons will be different, we can just pass it and say, look, the school ID is equal to the school that we're printing. So in this case, you know, SHS, their school ID. So we can build those buttons dynamically. And then away it goes. So it's nice and easy for that kind of stuff. And so, for example, if I go back to our courses here, templates, if we look at our catalog and our view catalog, this is where we, you can see it's not very much code actually to display this, and it's basic HTML. And I've actually used Bootstrap, so like makes it even more easy. But here, this is how we display all of our courses. It's that little bit of code right there that pretty much made our UI for all these courses, because it's going to reuse that same thing for every course. Does anyone have any questions? Feel free to throw them in there. I know we're kind of covering a lot, but I kind of want to just explore it a little bit so you can kind of start playing around with it a little bit if you wanted. Real quick, I guess just to show you, I'm going to real quick kind of build a new template. But before we do that, I want to talk about our base template. So our base template is kind of where we define the whole structure of all this. So you'll notice this one actually has quite a bit. And this is where we can define certain blocks. So we have our blocks. And basically blocks are like little modular, imagine like little modular bricks that you can add in to your templates. So this one's kind of like the full deal, but they're all empty. So you'll notice like here we have HTML, and this is kind of where our defaults are stored. So we have our HTML, our head. So this is where you would put all your head stuff, any meta tags, which is empty right now. We have our title block, and it just contains the title of the page. And we can, if we don't change any of this, so like if I were to go look at our template for schools, you'll notice that I don't have the title in here anywhere, and it still says demo. And if I don't override this, it's actually going to inherit from base. However, I could just add that block and override it and change the name of the title. So that's why I define all these little blocks, is so I can leave them or override them. And then here we have an includes block, and this is just where I can put all of my CSS links, my JavaScript. So in this case, it's just basically just plain old Bootstrap and Font Awesome, which is, I don't even know if we use Font Awesome, but anyways, Bootstrap is all there. And then we have our styles, which is where I put my custom CSS if you wanted a custom CSS. And you'll notice here, even for our custom CSS, because this is a file that's going to sit on our server, it actually uses the URL for function as well. Then when we get down here, we have our navigation. So all this up to this point is just our header here. And then when we actually get down here, this block content is where we actually put each of the individual page stuff. So if we look in this school one, this block content is really the only place that we've made any changes. And so also in this base folder, there's this empty, and this is what we're going to use. And I kind of have this there so I can really quick copy it and put it in a new template, like what we're going to do right now. So let's build a new template, just really quick. So let's go into, let's make a new view. So let's go, and let's say we want to show credit types of a school for the district, right? We want to show the credit types. So let's, those are at the district level, not the school level. We'll just build it under, yeah, let's do, yeah, let's say touch credit type .py. There's our credit type .py. We're gonna have to change permissions on it eventually, but for now, let's just do this. So let's actually no, let's copy one. Let's copy school.py to credit type.py, so that way it'll save us a little bit of work. All right, because really all we have to do here is change a few things. So we're going to set up our blueprint, which is kind of like where we define the view, essentially. So we're going to call this credit, and we're going to call it credit type like that. All right. And then we can actually delete our routes here. Let's do it the fast way. So then we're going to say at route. Oh, and it's actually credit type dot route. So here we're going to build our route file. And basically, like I said, our route is how we determine where we're going in our URL. And so we want to specify where we want it to be. So in this case, we are going to make it at the root level, and we're going to say credit dash types. So that's going to be our URL that we're going to use. And for our methods, I usually just put both so it can just do what it needs to. And it's not the best security practice, but for right now it'll work. And then we're going to define a function. We're going to say let's credit types. And then from here, we can just go ahead and write our stuff here. So let's query our data types. But before we query our data types, we need to query it. So let's make sure we import that data type. So credit type. We're going to say DB, or we're going to say types is equal to. Yeah, well, let's call it credit types. Credit types is equal to DB session dot query, and we are going to query credit type. Let's get all. And then we're going to return render template and it'll be credit. We'll call it credit types credit, 2 T's. Make sure I didn't misspell it anywhere else. Yep, credit types, and we'll call it all types.html. And we are going to pass it. It's going to expect a value of credit, variable called credit types, and we're going to pass it credit types. All right, so there's that. That's pretty much a view right there, and we'll actually come up here and rename it so the comment's accurate. Credit type blueprint. And I'm actually really quick gonna come down here and change that, and we're gonna, yep, credit type all types. Okay, let's save that, and then we are going to edit our app.py file. So we're going to say app.py because we need to add our new view. And so we're going to say from views.credit type import credit type. Which gets our file in there. And then we say register the blueprint we created credit type. Let's save that. And now the last thing we need to do is build our template. So we're going to go into our templates folder, and we're going to make a directory called credit types, or, oh, I hope credit type. There we go. I remember how we did that now. So now let's go in there, and we are going to, what we're going to do is we are going to copy our empty one. So we're going to copy our empty one, base empty.html, and we are going to call it, oh, now I can't remember what we are going to name that file. All types.html maybe? We'll check it here in a minute. Let's just leave it like that and we'll edit it. So now let's edit this and, you know, let's just see if that works. So we're going to leave that a blank one. Well, let's real quick, we'll just change this to say credit types. We'll just make sure it works real quick. Let's go back into our views and I'm just going to check and make sure that we had the right all types.html. What do you know? Okay. So now let's sudo service restart Apache. Sudo service Apache 2 restart. And let's see what happens. Now, I don't know if permissions are going to be an issue here. Yep. Okay. So there was an issue. Let's make sure we can just load the default one. Make sure, oh, nope, we have an issue somewhere. So let's check our error log. So we're going to say sudo tail var log Apache 2 error.log. And we don't have views.credit type. So let's see what we have here. Credit underscore type. So we're going to actually move credit underscore type to credit type. And then we're going to restart our server, see if we can get any further. There we go. And let's see what we get. And now I can't remember what we put there. So let's nano that guy again and credit dash types. Oh, I did an underscore, which is not very friendly to browsers. So let's try that again. And there we go. So we're actually getting somewhere because we actually have our empty thing here. So let's go edit our file, our template. Oh. We're actually going to get rid of all this. And now what we're going to do is inside of our content block, we are going to write our little for loop. So we're going to just say for credit type in credit types. So there's our for loop. Let's end it. We're going to say end for. Then in here, what we're going to do for now is we're just going to print in the big giant letters the name of our credit type. So here we can just say credit type dot name. We're going to save that and exit. And we made a change, so let's sudo service Apache 2 restart. And there are our credit types. So you can see that it's actually relatively pretty simple, you know, because that was pretty much a whole new view, a new blueprint, everything from scratch. Once we have that base file, it's pretty easy to say we can just add a new URL with some different stuff. So yeah, it's nice and fun. It's a great way, like if you want something. And what's nice is with your original app.back file structure, you guys have an empty slate really, you know, and you don't have to necessarily tie it to a database. You can start off just by building hard-coded content. A great example, so my business website is actually written in Flask. and it doesn't actually use any database stuff yet, but it's written in Flask because I just found that it was the easiest way to build my website, so it was expandable. I have unlimited possibilities. So if you just want to build your personal website using Flask, that would be a great way to start learning. And then what's nice is then you can start adding some database features. Just like eventually I plan on making it so when you request a quote, it actually goes into a ticket system, into a database. So that way, instead of just sending an email, it actually does something. But yeah, this is built in Flask. You can build your own personal website in Flask and then add database stuff to it later, whether that's just, leave me a note kind of a thing. So anyways, Flask, pretty awesome. We spent a lot of time talking about it, but I hope it gets you excited because, like someone said before, I'm glad the end of the course is over, and I know how it is. I'm glad that you guys made it through as well, because that means you're progressing and you're getting somewhere. But one day school is going to be over, and you're going to need something to do. And I hope that if anything, you guys get excited to see the possibilities, because I've seen a lot of students come through and database is not that flashy of a thing. But I hope that this kind of lets you see that, it can be flashy. It's a big chunk of what makes a flashy thing. And if you know the database side, the other side's actually, in my opinion, some of the easier portion of it all. So much rides on the database. So if you can just learn that other part, then you've got the whole picture essentially. So, and that's what I hope this lab did, is I hope it made you realize that, like, the whole picture isn't really that far away. Because really, like I said, in just part one of the lab, you guys have a complete running Flask instance. So anyways, yeah. But anyways, does anyone else have any other questions before we call it a night?
No, but thank you for all your help this semester. You've been an awesome, awesome, awesome instructor.
Thank you. I appreciate that. Appreciate that a lot. All right. Well, I will let you guys get to it. Because, with this, and I guess is a final word, lab 14, if you get stuck somewhere, share with me how far you got, because I'm pretty much going to give you credit if you attempt, because I get it. Finals are this week. You guys have all got other classes. So please, don't sacrifice something long-term, because I know you can always come back to this if you need to. So, if you get stuck somewhere, and please do not stress about getting those points. Just send me what you got, and take care of the things that are more important. So, anyways, thank you all. This will be the last meeting. It's kind of sad, really. But thank you guys all. I will certainly miss having you guys in here. You guys, especially those of you who are left, I know a lot of people can't make it because of time constraints and whatever. But you guys pretty much have been here for every meeting, so definitely appreciate that. And yeah, I wish you guys all the best. If you ever need anything, reach out to me. Feel free to connect with me on LinkedIn. I have a lot of students do that, and more than happy to. I love to see where you all end up. So best of luck and have a good one.